All right, let's get started. Thank you all for being here. My name is Salim Alam. I'm a principal dev at Chef, and I've been working on Habitat and Builder for the last 2+ years. And just a quick show of hands, how many people know Builder, what it is, or have used it? Okay, so quite a few. It's awesome. And really, the title of the talk is a guided tour Builder. We'll cover quite a few topics, but really what I wanted to do was give some stories about Habitat and Builder from the engineering perspective, and talk about some of the issues we ran into, the dev challenges, some of the, how we overcame them, things like that. I hope you find that interesting. And then also, we'll talk about things like new features and the roadmap ahead. And at the end, we'll have time for Q&A. So if you can just hold on to your questions until then, hopefully we'll have some time. So, all right, so let's get started. Okay, so I want to start right at the beginning, right? So, one question would be, what is Builder? If you're not familiar with Builder, what is it? But really, I wanted to start with why Builder, because that's kind of the question that came to my head when I joined the team, 2+ years ago. And so this is a little bit of recap for those of you already. Most of you probably already know this, and it's maybe a little bit of I'll just kind of go through it again. But with Habitat, you have this workflow, right? You've got your plan file, you've got an application, you've wrapped it with a plan, and then you will, you build it to create a runnable artifact, and you use the studio for that. And then, then you use a supervisor to deploy and run your fancy application or service, right? So you've got that going. But now there's, some key scenarios to also think about, right? Which is, first one, when you're installing your service, right? It's got to come from somewhere, right? So where is that? And then every once in a while, the supervisor is going to pull and say, if there's any updates to the running services, and so that's got to come from somewhere, right? That's a key scenario. And then every once in a while, the supervisor is going to self-update itself, right? So that's also part of the scenario where it needs to do installation of updates and packages, right? So there's a number of different questions here, right? So where are we hosting these core packages that form kind of the primary corpus of packages that get used? And then where are we hosting the community packages and the proprietary packages that you might have? And then another question would be about establishing trust, because you not only have to download a package, but you have keys that sign the packages, and then you have keys that also verify the packages. So that's got to come from somewhere. And then the channel awareness. If you're using Habitat, that's channel used key part of the workflow. So that metadata has to be somewhere. And then this notion of reverse dependency build. So if you've used the standard package management, right? You've got this notion of forward dependencies. So there's a notion of you've got a depth solver. I don't know if anybody's ever gone in that deep and looked at what that looks like, but I know there's a couple of people at Chef that have written one. I've debugged one, and it's you reach your level of sanity trying to kind of figure that out. But fortunately, with Habitat, we don't have to worry about that, because the way Hab works is that you have a single dependency chain. So we're not worried about forward dependencies anymore. We're worried about reverse dependencies. And that becomes important. So if something changes, you have to be able to build all of those packages that depend on you, because the ideal scenario there is that you want to have come in the next morning. Let's say there's a security issue or something, and you have everything already up to date and ready to go, and so there's no conflicts there. So that's that's another thing that you need somewhere to be able to do those builds. And then this other notion of other services that are out there, we need some sort of integration point. You can export, for example, to Docker Hub. That's a great service that could be provided, right? Extensibility is another big thing. If we have APIs, then people can add on and build more things that we haven't been able to build, and so that's where APIs come in. And then another thing that we've kind of thinking about is just showcasing the capabilities of Habitat in a pretty easy way. If you have a website somewhere that somebody can go to and experiment with it, wouldn't that be a great thing? And then the last part, last but not least, was this self-hosting notion, right? If we're building Habitat, then we also want to be able to use Habitat in a way that people would in the real world, right? When it's out there. So all of those things were kind of the why for having something like Builder. And so the what part, this is one way to kind of think about it. It's really platform and services for your deployment automation, your dependency management, and build orchestration. You can certainly define Builder in many different ways. This is how I kind of chose to define it here. But then the bigger message is that it's really kind of thinking about Builder as one part of kind of this three-legged stool. You've got the supervisor, you've got the studio, and then you have Builder that kind of completes it out. Right, so if you don't have any one of these things, then things can maybe fall apart, and it's more than kind of the sum of the parts. So that was basically. Hopefully, this convinces you that if we didn't have Builder, we would need to go build something like it, right? Because it satisfies all of these needs in the kind of Y column. Okay, little bit of a side topic here. I want to talk about terminology and licensing. Terminology because I'm going to use these concepts later. So depot is a part of Builder. It's the package repository part. And then we have the other part of it, which is the build pipelines, right, that actually produces the build packages. So there's those two parts. And then the Saas Builder is the cloud web service. It has the depot and the build pipeline. And then the on-premises Builder, which is the private version of Saas Builder, which only has the depot at the moment. It doesn't come with build pipelines. So that's just kind of terminology as I'll talk about these things a little bit later. But one other thing I wanted to talk about before we get into really the meat of the discussion was licensing. And this is kind of my public service announcement. If we haven't talked about this enough already, but we did announce a new licensing model for Chef in April. And Chef is 100% open source. And the great thing is, Habitat and Builder has always been 100% open source. So there's not a lot of changes here for us. But I did want to walk through a few things, especially what this means for Builder specifically. So there's no immediate changes for the Saas Builder here. We will not be doing any hard enforcement for the licenses, so there's no DRM or anything like that coming. And if you have your existing Hab workflow, if you're already using it and you're uploading packages, those kinds of things that will continue to work. The only thing that's going to be new here for you is when you upgrade to new Hab clients, you'll need to accept the new license. And then Saas Builder, this is the only main ask here, is that Saas Builder really supports packages that are built with the license builder. So that's one thing to keep in mind. And then for the on-premise builder, the install script, when you rerun it, you just need to accept the EULA. So that's it. Should be pretty straightforward. There shouldn't really be much impact from a licensing perspective for you if you're using Builder today. And then here's a link to the FAQ if you have questions or about licensing and so on and so forth. Okay, so let's get to the fun part. Okay, so I talked about self-hosting before, and self-hosting has been really super, super important for us right from day one. And Builder itself is a set of Rust-based Habitat services, and I'll talk more about the Rust aspect a little bit later. And the other thing is that we manage the Builder services with Habitat. So all of the service bindings, all of the configuration, all of the updates it's HAB. And here's another thing that's interesting. You might not have known this, but Builder self-hosts itself. And I'll describe how that happens. It's kind of a recursive thing, but that's pretty interesting about Builder. And then the last thing is that the engineering team that builds Builder is also the team that operates Builder, right? So we don't have two different teams. It's actually a pretty small team, anywhere from 1 to 3 engineers, depending on any given time. So not a large team, but we do all of that stuff ourselves. And that's part of the self-hosting ethos on the Builder team. So, okay, so here's part of the story. When we first started doing the development, this is what we were doing. We were first starting to bootstrap Builder itself, right? So all of those different Builder services didn't exist. Somebody had to write them from scratch. And at the same time, we were bootstrapping the platform that was the scaffolding for Builder too. So that platform, which was HAB, didn't exist either. So that was being built. And then we were also bootstrapping the dependencies. We had no other core. We needed core plans for things, but we didn't have them. So that was a work in progress. And then we were using Rust. And I don't know if folks here are familiar with Rust, but Rust is a great language, but it has a very steep learning curve. It took us months and months and months, many, many months to really learn how to use that language efficiently. And even today, new people coming onto the team, there's a pretty steep ramp up with that. So we were struggling with those kinds of things. And then while this was happening, the tech stack was also changing. So we had Redis as the data store in the early days, but then we decided at some point to switch that over to Postgres. So that transition was happening. And we didn't really know as far as what was the incoming traffic that was going to be. The first thing we did was we built a Saas builder, and we didn't know, on day one, is it going to be 100 people or 1,000 or what was going to happen. So we didn't really have much data there. Very rough monitoring and metrics. I think other than basically the stock AWS metrics, we didn't really have anything on the services. And then the scale goals, I'm kind of being polite here by saying they weren't clearly defined. We didn't write anything down. We knew we wanted internet scale, but it wasn't really written down specifically. So I don't know, maybe this is familiar with the types of challenges that you might face in your day-to-day work, but as a startup, this was pretty typical of a startup environment with the kinds of things that were happening, and we were operating in this mode. So here's what things look like. We drank the microservices Kool-Aid pretty hard. So if microservices were good and the thing a few years ago, and they were, so then more services were more of a good thing, right? So we had 10 services initially. The front part, pretty standard, there was reverse proxy and then API. And then we had the data store, but then you had different services for user sessions, different service for admin, and the origins, and then the job server and the scheduling. And so all of these things were kind of in the mix together. And then the second decision that was made kind of early on was to have this centralized routing as part of the system, so that when the API was trying to get to anything at the back end, then it would go through a centralized router, which is, this was kind of an early attempt to build kind of our own L7 kind of routing, load balancing, proxy in the middle. But this is essentially what we ended up as the architecture. With there was a custom networking protocol at that point. And then the third part, this is 2017. This was around the time we were kind of starting to go GA. I think we went GA late in 2017 in the fall. So part of this was early, and part of this went through GA, where we were storing all the packages on the file system itself, which was kind of an issue because we couldn't scale out any of the API nodes early on because of that package dependency. And so it was a single node API. And at that point, we just didn't know, in terms of the performance and latency for these services, what was happening there. We just had very little knowledge at that time. So after we went GA, we started starting to look at deeply into what was happening in the system. starting looking with Nginx access data and starting to instrument the API calls and the timing for them. Same thing with the database access and the timing. And then we started adding some custom dashboards. You can see some examples on the side. And we did some scale testing then. And so the findings were pretty interesting. We saw that 90+% of the traffic that was coming to us was really one single question, which is, in my first couple of slides, those 3 scenarios, like supervisors always asking what's kind of the latest update on a given package, or somebody's installing a package. But most of it is really what is the latest update on things. And that's not something that you can cache, because you want really the real-time results there. So a lot of traffic comes in for that, and then there's other stuff there. And then the other thing was, when you come in and it hits the API nodes, then all of a sudden it fans out into the back end. So we have these things that put 1 to 3 or even 1 to 4 amount of load on the back end for answering that question. So that then led us to see that the database that as we had it was seriously underpowered for how much traffic was hitting it. And we were starting to max out at very low numbers, like 40 requests per second, and you'd start seeing these maxes. It was pretty embarrassing to see that. But most of all was this, right? We didn't really need any dashboards to see that, because we would get paged, right? We would have pages in the middle of the night, and you'd get up and try and figure out why. And a lot of times we didn't even know why. I mean, it was we were hitting thresholds, but wasn't always clear exactly what was happening. So that's 2017. And then very quickly we started to simplify things. You can see the last slide, there was a lot of errors, a lot of different places, and this is much fewer errors here. So that started with consolidation of these services into something that's started to become a little bit more sane here. And then another big thing, we moved the packages into S3, and that at that point it wasn't on disk, and we could have these multiple nodes. And that made it easy to do the horizontal scaling for these services. At that point, we still saw that the database was loaded. We still had work to do there, but things were slowly getting better. And we were still, unfortunately, hitting the same limits. And latency was not great, right? So just internal latency measured for the response times was in the hundreds of milliseconds. So that wasn't great at all. And and here's kind of a dashboard. So just in 2018, we had 19 hours of downtime. And we had how many incidents? Maybe 20 incidents or something, quite a few. But the funny thing is, in spite of all these shenanigans happening, we were still at 2 nines. So it was 99-point-something%. We hadn't hit 3, but we were doing better than 99% with that architecture that we had, with all of its flaws. So that was good to know. So we started doing some estimates, and I just copied pasted exactly what we had on a back of the envelope calculation. It's just exactly what it was. We said, okay, look, let's do some thinking here. We have this today, 100 to 300 milliseconds. Let's say we have 50 threads. How many are we handling? We should be able to do 100 to 500. Well, we're doing 1/10 of that, right? So that's bad enough. But then we said, okay, what if we put a cache in front of everything, right? And now if you have a memcache, 10 milliseconds would be, conservatively speaking, you can do, that should be fine. Same number of threads, same number of everything. And now we should be able to go up and do 5,000 per second, right? So that kind of became a rough goal just based on this back of the envelope thing in terms of scale computations. Okay, so where are we today? So this is what the thing looks like now. And you can see it is so much simpler, right? There's still some microservices. We have the job server and the worker. We can consider those microservices. But the other pieces became much more consolidated and much more simpler in terms of the connection flow. And so we did that. We added the caching, the memcache at the API layer. Did some optimization of the SQL queries that was going back to the backend. And we found database utilization went down dramatically. And communication, there's no more centralized routing, so that went away. And the result was we hit 4,000 requests per second with 1 millisecond latency, right, with these changes. So that was 100x improvements in performance and latency on a running system with, with other changes that then happened in terms of our uptime. So our uptime went to 99.97%. This is year to date. I just measured this, and that's what it is today. We had, sorry, go back here. I thought I had a little, snapshot, but we had basically this year to date just 52 minutes of downtime on the service. And that's compared to 19 hours in 2018. So another huge difference. So the team slept a lot more this year than they did last year. So yeah, lessons learned. Keep it simple. It's totally cliched. It's easy to say, hard to do, I guess. If I had a dollar for every time somebody said keep it simple, I'd have a lot of dollars, right? And then we had kind of fallen into the over-engineering trap, right? There's a lot of moving parts that we didn't need. And so that's the other thing that we've kind of learned from this. The measurement clearly was extremely important. Until we were actually measuring things in detail, we didn't know what was happening. And then the back of the envelope calculations were super useful. And then the last 4 things were really things that lessons learned from the HAB perspective, right? So reviewing the service dependencies. And this is something that HAB made it really easy and explicit because you have your bindings, you're declaring everything there. And so you can easily see what are my dependencies, how are they bound together. You can have a pretty good idea of when you want to do those reviews, what's happening in the system. Another thing that was interesting, the pattern that, so if you're using HAB, the general pattern that you want to use is you roll forward, right? And so if you have something, you have an incident or something, you roll forward, you build a new thing, and then you apply the update and you're good to go. But we also learned that there are cases, a couple of times a year, we have rolled back, right, for different reasons. And I'm here to tell you that if you have to do it, you're okay, you can do it. Habitat does make it possible. So don't think that you failed because if you had an issue with your packages and you said, I'm just going to roll back for now. We've done that ourselves. And then the other thing that was super useful for us is, again, this is the HAB thing. You can HAB config apply all the configs for all your services from just one place. That was super, super handy. If you're in the middle of the night, you're waking up for an incident, it's nice to be able to have just one central place. You can change configs around your settings and just apply it. So that was super useful. And then, of course, updating often. This was really important because we found that the more things that we packed into these releases, then if there was an issue, the harder it was to either update it or roll it back. And the best things, the best way for us to operate was constant releases. Multiple times a day we've done builder releases, just kind of keep it flowing out there. And that way you have smaller things, easier to control, easier to QA, and easier to roll back if you have to. So so those were some of the things. Let's see, are we doing okay on time? Yeah, not too bad. Let's see, self-hosting, really quick. We have 2 environments, live and acceptance. And if we have any changes that come in, they get auto-built, builder builds, and I'm talking about the builder services. You get those built. And then the supervisor on the acceptance environment will just keep picking them up, keep updating them. And then when we're ready to release to live, it's just a promotion. And and then Builder will self-update itself with those promoted packages. And pretty much all of the time now, especially since we have those 2 API nodes, that's done without taking any downtime. So this really is a zero downtime situation for running service that is updating itself. And I don't really know of any other example of services that do this type of thing. So this is, I think, in some ways pretty unique. But again, the power of Habitat applied to these services lets us do these kinds of things. So yeah. OK, so I'm going to talk about on-premises Builder. Next. So we have about 15 more minutes. Quickly define the flavors. Saas Builder is cloud-based, authenticates with GitHub, and has the repository and the build pipelines, right? We talked about that already. And then on-premises, it's enterprise installed and managed, so you get to install it if you want to use it. And we've got expanded authentication, so you can use OAuth or OpenID Connect, GitHub Enterprise, GitLab, even Chef Automate can be a provider, but it's depot only. So here, so one other, before I talk more about that part, so one other thing I wanted to talk about was the job server capability, because that's not something that's in on-premise. So how does that work? And so how that works on the SaaS side is we have this centralized model where every package in the system is connected together with its dependency chain, right? And so that's, we've got the overall build graph. And then if all the dependencies for the graph come from the package metadata, because every time you build a package, we put that into the metadata, and you upload it, and we know we can update the graph with those dependencies. And then we have a job scheduler piece that on every change that comes in, if you've connected your plans, then it does the builds for you, and it goes and consults the graph, and it figures out what to build first, and then what are the things you can build next in parallel maybe, and then kind of keeps track of the job state. So at the end of it, it's responsible for getting, whether it's one build or you could have 100 builds because you were rebuilding the world because something at the bottom of your graph changed. So it's responsible for making sure that gets to completion, right? You might not get 100% success rates for all of the packages, but you're going to get to the end, right, one way or the other. And so that's, things can go down, the whole system can go down, it'll come back up, and it'll say, here's where I was, and it'll just take it and finish up those jobs for you. So that's what it does by tracking these build states. OK, so you don't get that on premises. It's not available, and it's really for 2 reasons that we haven't shipped this yet. First of all, is GitHub only. So the source repository connection is not there for anything other than that. And what we've seen in the enterprise is a huge variety of different ways of having your source out there. So that part is one of the reasons. But then the other reason that we don't have the job server for on-prem yet is because we're also trying to reconcile it for the existing CI that is running inside of your environments, right? So you could be running a Jenkins or Circa CI, whatever it is that you're already running and used to. How does that fit in, right? It's not always easy to kind of fit those 2 things in. So those are a couple of the key reasons why we haven't released it yet. And so here's kind of the thinking, but again, this is something that we're also wanting to get more feedback on from you, right? But I just wanted to kind of outline what our current thinking is here for on-prem. So you bring your own CI, you can even bring your own data store. Some people are running their own Postgres instances, and so you don't have to deploy our instance. You can bring your own package store as well. Today, if you're on-prem, you have Minio, but we want to give you more options. And then, hey, maybe we can provide build graph as a service. And if we do that, then the other parts that I just described might not be that big of a deal to hook into your existing CI, right? And get a build pipeline going. So this is what we're currently thinking. But again, this is still a work in progress for on-prem, and we're kind of looking for feedback from you guys that will guide us in terms of what we do next. And then the other thing is it's pretty lightweight. If we move the states out, if you're managing the state, then to just deploy a couple of services, you could deploy that literally anywhere, right? And if it goes down, there's no state. If it goes down, comes back up, you're good to go. So that's kind of the current thinking on on-prem. Now, I said, bring your own package stores, Minio today. We do have an alpha that we just released for Artifactory as a package store. And it's really fairly easy, right? There's only 3 things we need. We need to set the enabled to true. We need a URL for where your instance is and your API key. And if you want to change the repo name, you can change it, but there is a default. And then you just run the install script and for on-prem. And that's it. You have Artifactory instead of Minio as your depot. Now, how that looks like under the covers, because it's still alpha, you don't depend on it. If you do this, don't run your production thinking that nothing's going to change, because it probably will change. But to try it out and give us feedback, that would be awesome if you want to do that. So we have that as the first thing. And then the other thing is the graph APIs I talked about for figuring out your build ordering and dependencies. That's also out there now. So we have 2 things. One is you can list your reverse dependencies for any package. That's kind of the API path. And this is in our docs. If you go to there's a YAML file that describes it. But then also, if you want to find out what is the optimal grouping in terms of building these things, we have that. And that's kind of a sample response for the grouping. So you can see if you have one thing at the root, then you can say, OK, you can build in group 0. You can build these packages. And then once you have that, you can start your builds for these other ones. So that's the kind of intelligence that we can provide using the graph APIs. These APIs are actually present in the Saas builder today. They're not quite there on-prem yet. We need to do a little bit of work to get them to you, but anticipate that those will be coming next, and we'll make those available. So so that's what I have about on-prem builder. And then the last thing, last couple of slides I have here is kind of the road ahead. So we have, we've done all this. If you looked at the last many slides, it might sound like all we've done is, mess with the infrastructure and make it more efficient. And yes, we did spend a lot of time there, but we have a few new things too. So one thing is origin deletion. Before, if you had an origin and you weren't using it, you couldn't delete it. We've added the capability now. This is all stuff that we've done in Q1 and Q2. So you can do that, clean up a little bit. And then we've also added package deletion capability. So this is something we've never had because we, from the beginning, wanted to avoid this. There was this scenario, I think it was a node package. It was some very central package. Somebody deleted it, and it broke the internet, right?
Left pad it was called.
OK, yeah, left pad, OK. So we wanted to never have that scenario. So anything that you put in Builder stays in Builder. But there are scenarios where you absolutely want, maybe there's a security thing and you don't have any dependencies. There's always some special cases that it is OK to delete these things. And so we've now enabled you to, in some scenarios, be able to do those deletions. So that command is there, shipped in, the CLI part shipped in HAB 8.1. So that's available. And then the other thing we've done is we've added Windows build workers into the Saas builder pipeline. So previously we didn't have that, and now if you have a planned PS1, you can connect that to Builder, and you can also connect it if you have one package that has a plan SH for your Linux side, and you also want to build a Windows version of the same package. You can do that with having 2 different files sit in the same directory, and Builder's smart enough to pick up both of them if you've specified one. This is my second to last slide, thank you. And then Linux 2 build workers, if you have an older kernel, not a lot of people are impacted by this, but we do provide that capability. And then I mentioned the Graph API already. So those are things that have recently come in. OK, this is the last slide, and then questions. So path to V1, we're not V1 yet. And what we're prioritizing is things like stability, maturity, and addressing the key pain points that you have before we can say we're happy with where we are and where we want. And so we know on-premises is a pain point right now. We want to reduce the friction there. So we'll do the improvements in installation. Air gap is another one that we don't quite have nailed down yet. So we want to do some more work there. Package synchronization is another thing that we have a script, and actually there was a talk yesterday. Skylar Lane from Indelliant gave a talk, and there's some really cool work that he's done with package synchronization as well. So those are kinds of things we definitely want to see improving in the ecosystem. And then, as I mentioned, better integration with existing infrastructure that you have on your on-premises environment is another theme for us as we move forward there. And then other things that we, just table stakes things, right? We know, searching. If you're searching for packages, it's not a great experience. We want to improve that. Web UI and the HAB CLI, they don't have parity. Some things you can do with the CLI you can't do with the UI, and vice versa. And then APIs and documentation, we definitely want to get that pretty solid. And then bugs and issues and things like that. So kind of hopefully gives you an overview of directionally where we're headed before we say we're V1. And that's it in terms of slides. I'd like to now maybe open it up for questions and go from there. So.
Do you have any recommendations on maximum package size, or what we should be doing with large packages?
Well, I don't have a recommendation, but we've been tweaking it over time, right? Because as these packages get bigger and bigger, now you start getting over a gigabyte, you might have performance issues just uploading it gets pretty large, but there isn't anything super inherent. There's configs in Builder, both the SaaS and on-prem, that you can adjust and be able to support much larger package sizes that might be there today. So it really is. But there's a lot of configs there. Sometimes it's on the load balancer side, like in AWS. But most of the configs are inside of the Builder or Nginx.
Thanks, Salim. That was really informative. There was one section that you talked about your own management of the Builder service, and you talked about centralized configuration. Can you go into a little more detail about that? Are you using like a permanent peer ring for your Builder service yourself? When you have configuration changes, are you shipping those configs through a pipeline to wherever that destination is?
Yeah, we do have Bastion nodes in the ring, so we have that kind of topology where you have a few extra nodes to persist this gossip state, and that's definitely been helpful. I think that's part of the pattern that's already in our docs as well. And then for the centralization, it's it's not anything more than having it in our own like private source repo, right, and keeping it on a certain node. And so it's basically kind of having this mental model that if you want to change config for multiple services, you just go to one place and just issue one command. So,
So in that case, so somebody is logging onto a system and changing like a user toml?
Yeah.
Okay, got it.
It's not a user toml. It's just a HAB config apply of a toml, right? Yeah.
Thank you.
Thank you. Just a question on your architecture diagrams that you had before. The perception that I got was your performance increased as you reduced microservices. Was did you find that the implementation between the microservices was causing the problem, or just that's how it fell out?
Well, there was no one factor, right? The thing is, there were so many things in the mix. And so it was the communication of the microservices, how efficient that service was, what queries it made to the database, right? Plus the factor that you had load that didn't need to be there. And so, it was a combination of things. And it wasn't, and we saw incremental improvements as we did some of these changes. We saw, before we got to 4,000, we hit 300, right? 300 requests per second. So that was the next big jump. And so then we kept tweaking, kept changing things until we got to that level of performance. But reducing the microservices definitely helped, and especially because the team was so small. And so it was kind of this thing where, this cognitive overload is really a thing, right? And the more you reduce moving parts, the better off you are.
Was that initial state part of the over-engineering?
Yeah, I think so. I think this is when you're a startup and you're starting from nothing, right? You're gonna make decisions, and and then in hindsight, there'll be things that you'll say, oh, well, we should have done things differently. So that's kind of the way things evolved. There's one back.
You mentioned early on in the talk that you, I don't know, maybe not you, but maybe you were part of the discussions to choose Rust as the language of choice for implementation. And it sounds like that may have been an impediment. I'm just curious, maybe you weren't privy to the discussions, or maybe you were, what some of the reasonings were behind choosing Rust despite its steep learning curve as opposed to something like Java, where most people would have experience.
Yeah. So that's a really good question. So the Rust thing, it was a decision that was made way before I joined the team. And the thing for Builder, though, is that Hab is built using Rust. So for Builder, it made sense to use Rust because you could use the same, libraries, the common libraries and those kinds of things. But then there was a big downside as well, because it took a lot longer to build things that might not have taken that longer. We could have put together a few APIs using Node, for example, right? We could certainly have done that. So that was kind of the downside. But I will say Rust is an excellent systems language. And the benefits paid off later on. When we were doing this refactoring, there was a ton of refactoring that was done. And we could do fearless refactoring because these classes of problems that we see with other languages didn't surface with Rust. And so it hurt us, but it also helped us tremendously. So
Do you think it's better in the long run?
I think it's better in the long run, given where Hab is and the Hab, code base and the mindset and all of those things. Yeah.
Do you know if there's any plans for support of ARM architectures for running the Builder or building packages?
I don't know definitively, so I'll maybe answer that later. All right, looks like that's it. Thank you, guys. Thank you for coming.